Good day, viewers. You are welcome to Physics with GSO. This is my introduction to the physics lessons at SSS1 level. I am Professor Oludotun James, a physics teacher for over 5 decades in Nigeria and a few months in Zambia on a technical aid call service from Nigeria. It is my great desire that anyone interested in learning physics will find these lessons very useful. The scope of these physics lessons covers the ordinary level physics curriculum, which prepares learners for entry into any university science degree programs. To achieve the goals entrenched in these lessons, a good knowledge of the ordinary level mathematics is required. However, in order to enhance your success in science career now and in the nearest future, you are strongly advised to study further mathematics at the ordinary level. This is because mathematics is the language of science at the university level. As you go through these lessons, the knowledge of mathematics required of you at every stage will be explained to you. Also, at every stage of the lessons, you will be required to solve problems as a way of evaluating every lesson. You are also required to do so as self-evaluation to every lesson. Lastly, as part of my introduction to these lessons, let me explain to you why the theme energy quantization has been entrenched or included as part of what you have to study at this stage. Two branches of physics have emerged by the end of the 20th century. One, the classical physics or classical mechanics, and the quantum physics or quantum mechanics. When the three laws of motion were propounded by Isaac Newton, scientists believed that all the problems or the questions concerning the description and explanation of motion and energy of matter have been well answered. These laws constitute the classical physics or the classical mechanics. Recall that the laws were used to describe the motion of planets and to predict the eclipse of the Earth. However, when it came to the point of describing or explaining the motion of the subatomic particles, the use of classical physics or the classical mechanics broke down, especially when it was noted that the speed of these subatomic particles were observed to be close to the speed of light. Thus, the new theories and principles of physics that emerged were classified as the quantum physics or quantum mechanics. The history of quantum physics dates as far back as when the concept of the atoms and molecules were conjured to describe the structures of matter. That is, what is matter made up of? Dalton's atomic theory got the answer rolling, thus making scientists to formulate the models for the atom. Bohr-Rutherford model produced the planetary model of the atom with the nucleus at the center and the electrons revolving around the nucleus in their specific orbits. The nucleus of an atom consists of the massive positive protons and the neutrons, which have no charges thus making the atom neutral. The following are the consequences of the quantum mechanics or the quantum physics. 1. The inclusion of Planck's constant h and the velocity of light c in the description of the motion of the subatomic particles. 2. The particulate and wave nature of matter, that is, the dual nature of matter. 3. The electrons of an element move in orbit round its nucleus with certain package of energy called quanta as they revolve round the nucleus of the atom. 4. The outcome of the periodic table when atoms of elements are arranged according to their atomic numbers to show their chemical behavior. 5. The emergence of the group 8 elements, that is the inert gases, with their s,p,d,f orbitals with the maximum number of electrons around the atoms. 6. The production of the line spectra when electrons are excited. 7. The uncertainty principle in the measurement of the position of an atom and its momentum. I will now ask you to join me in the presentation of the first lesson to this Physics with GSO. Thank you for listening.